Okay, this is the start of partial fractions. So the main idea about partial fraction is we are breaking down a big fraction into smaller fraction. So there is a huge fraction here. We're going to break down into a few small fractions. So how we break into smaller fractions, it is all dependent on the denominator. So later on, we will see that, right? It is the denominator that decides how many small fractions that we have. Okay, so before we go to that part, we got to run through a few basic things first. So for the first thing that you will need to check, you need to check whether a fraction is proper or not. So what is proper? So we will be checking proper fraction versus improper fraction. So later part, I will show you how do you check for proper and improper fraction. So if it's improper, it is very important to do a long division. So if you fail to check this one, and if it turns out to be improper and you forgot to do a long division, the whole question is 0 marks. Okay, so in any case, right, if let's say you realize that it's an improper, you are going to do a long division in this way. The long division will look like this. The numerator is inside. Then the denominator is outside. Okay, so this is how you carry on with a long division. So we will talk about that later. So first step, we will need to check proper versus improper. Okay, second step, you will need to check whether the denominator can be factorized or not. So factorize, back to the basic method, take out common factor. Cross factorization, and a squared minus b squared. So we still have the method for grouping, but we don't use grouping factorization that much in partial fraction, seldom. Okay, so you got to check for these three methods, whether can it be factorized or not. So basically you need to assess these two steps first, then only we can check which cases are possible. So only a proper fraction. So you can only reduce a proper fraction into these cases. You can only reduce this a proper fraction into these three cases. So let's observe the three cases first. So the first case, the denominator are linear function. So if the denominator are two linear function, it becomes two simple fraction. If the denominator is being repeated, there's a power 2 there. So that means one of the bracket is being repeated. So you will make it into three of them. So the one that is being repeated will progressively be starting from power 1, then power 2. The last one is the one that you encounter a non-factorizable bracket. So this is still linear. This one is a quadratic, but you cannot factorize. So look at the quadratic, it is a plus. So it's different here. This is a minus. If it has been a minus, then maybe there's a chance that you still can factorize. Okay, so if you can't factorize, you have to introduce a linear numerator. So that will be your 3 cases. So later on, I will be showing you each of the case. So you perform step 1, step 2, step 3. After that, you got one last step. You got to solve for the unknown. So that depends on your step 3. So for example, here you got 2 unknown. Here you got 3 unknown. Here you also got 3 unknown. So you got to solve for the unknown by using the concept of identities. So basically, I'm using the technique in identities. So techniques in identity will be by substituting values, or we will do a compare coefficient. Okay, so that one is under the identities concept. So this will be the 4 main steps that you got to check before we can even start a simple question on partial fraction.